Yes, and we were at the hand shrine. Yes, we were at the hand.
Historical place in Japan.
That's right.
It's occasion just to that they have
Here earlier.
Last week we saw.
Last week, so we saw many
very
nice,
beautiful.
yes.
Yes. Monday and Tuesday we were in Tokyo. Things that possibly.
The international interest in the science of the environment has been growing over the last 2 decades, and the quality of the science that is being carried out internationally has become extremely high, and I think that is recognized by the choice of the JapanPrize committee that environmental science and technology should be one of the categories for which the prize is awarded this year. In the course of our experiments, we soon recognized that the only method by which these compounds can be removed from the atmosphere is to be destroyed in the stratosphere, in the upper atmosphere of the Earth. And when we continued our investigation, we found, to our surprise and dismay, that the destruction of the chlorofluorocarbons would also be accompanied by substantial destruction of the Earth's protective ozone layer. But as we know from the work in Antarctica by Dr. Tsubashi of the Japanese Antarctic Group and of Dr. Farman of the British Antarctic Survey, and then from the NASA satellite measurements, the substantial ozone loss has occurred over Antarctica, and it is now well established that man can interfere with his atmosphere in a major way. During the last 2 years, we have been seeing remarkable progress among the nations of the world in agreeing to control the emissions of the chlorofluorocarbon gases. The agreement known as the Montreal Protocol called for a 50% reduction in emissions of the fluon gases by the end of this century. This agreement was an excellent first step, but it does not go far enough. The studies in the atmosphere in the last several years clearly show that ozone depletion is too dangerous for us to have it continue to get worse. And so we must go beyond the Montreal Protocol to 100% elimination of emission of these gases to the atmosphere by the end of the century, and hopefully sooner than that. But the international cooperation, and both in study and in regulation, that has been established with the fluon gases will be very useful as we study and need to control the emission of other gases in the future. And I thank the Foundation again for having given me the honor of receiving the JapanPrize in Environmental Science and Technology. Thank you.
And I appreciate deeply the confidence and appreciation of my work in chemical sciences, especially synthetic chemistry, by my Japanese colleagues. We selected this research project for several reasons. One of them being the fact that these were a brand new family of substances produced within the human body which had very powerful biological action. These compounds could not be studied in biology and medicine without a larger availability. And so it was clear that they had to be made by chemical synthesis for further scientific investigation. The chemical structure or architecture of the prostaglandins was quite unique to these compounds and different from any of the known biological hormones or regulators. The design was successful, and by 1969, processes had been developed for the chemical synthesis of all of the known prostaglandins, each of the more than 20 biologically active compounds in the family, on any scale. Our chemical synthesis has been repeated in more laboratories than any other synthesis of a complicated organic molecule. Soon after the completion of the synthesis, prostaglandins became available easily all over the world, and this led to an explosion of biological studies and medical studies of the effects of prostaglandin on every cell and every kind of tissue and organ of the human or animal body. These biological studies have led to a very much deeper understanding of the normal function of human cells, organs, and tissues, and also to the underlying cause of various important diseases. The award of the JapanPrize also draws attention to my field, the chemical synthesis of biologically active and important compounds. That area of science has made massive contributions to the welfare of mankind for more than 100 years. But I have been working on prostaglandins now for more than 20 years.
ということが分かりまして、それによってオゾン層が破壊されるということを理解するそうに至りました。
これまた難しい名前ですが、そのプロスタグランジンおよび関連体の合成法を書いたところです。
Commemorative medal from the Tokyo Metropolitan Government.
どうもわかる。ございます。
Thank you very much.
これ東京の写真場です。どうぞ。
The photo album of the Tokyo Metropolitan Government.
Thank
Thank you very much.
江戸古文と言いまして、古い昔の東京が江戸って言われた時代からある染め方です。
Edo Common, which is a representation of an old method of dyeing clothes that dates back to the era when Tokyo used to be called Edo.
Thank you. Wonderful.
第5回日本国際賞記念講演会を開催させていただきます。
And what I want to talk to you about today is some experiments and investigations that have been carried on in connection with the atmosphere and the way that it is changing with time, and especially the way it has been changing with time in the last 15 or 20 years. the introduction to the atmosphere, as far as my own research is concerned, began with measurements which are shown here. And on that voyage, he made measurements of the composition of the atmosphere on a regular basis, as shown by the green dot. The visible radiation, which reaches the surface of the Earth, ranges from the red, the next slide please, to the blue and on into the violet. We have, in addition to the visible radiation, the infrared radiation, which is with wavelengths longer than the red radiation. This I'm putting here just the wavelength range with the solar range from red to violet. And I'm going to talk about three ranges of ultraviolet. There's the ultraviolet A and B and then the C over here. And they can only decompose if they drift up into the atmosphere above the ozone and are exposed to this intense ultraviolet radiation and disappear as we had said they would. And the procedure for this investigation in the stratosphere is to bring back air samples and see whether trichlorofluoromethane is in those air samples. Thank you very much, Professor Shibata. On one side, the chain of 20 carbon atoms follows, connecting finally to the very end of a chain of 20 carbon acids, which holds 4 unsaturated units, very familiar to those of you in the audience who are chemists. In addition to the phospholipid part of the membrane, there are many proteins which are embedded in the phospholipid, which serve important functions in the cell. For example, to transfer ions in and out of the cell, ions such as sodium or calcium. Here is another chemical slide which shows 20 carbon unsaturated fatty acids. And you will notice that these three structures at the left of the slide differ in the number of double bonds or unsaturated units which are present. This one has 3, 1, 2, 3. This one has 4. This is arachidonic acid. The E prostaglandin of the first family and the E prostaglandin of the third family. So there are many similar structures which occur depending on the precursor polyunsaturated fatty acids. This is a normal process for the repair of damaged blood vessels. It is also involved in various disease states.
As most of you probably know, Professor Rowland is quite well known as a physical chemist and nuclear vehicle chemistry of tritium. But since 1974, he is known to the people even now.
We in organic chemistry have a major responsibility to train scientists for that industry. And we have a major responsibility to communicate across the boundaries of different countries and the boundaries of science.
It could be directly related to the could directly be applied to the human health and welfare. And in your lecture this afternoon, you indeed demonstrated that organic synthesis is playing a key role in medicinal science. Well, in subject, but providing quite general and very powerful tool to make a very, very important compound in medicinal science.
ただいまから第5回日本国際賞の授与式を挙行いたします。この式典に天皇陛下、皇后陛下のご臨席を賜りましたことは、国際科学技術団にとりまして、また日本国際賞の受賞者にとりまして、誠にこの上ない光栄の至りであり、深く感激、感謝してやまないところであります。また、原衆議院議長、土屋参議院議長、矢口最高裁判所長官、諸外国の大使をはじめとしまして、内外から多数のご来賓のご出席をいただき、このように盛大に授与式を挙行できますことは、誠に大きな喜びであります。
この度、ローランド博士に対し、贈賞の対象となりました研究のテーマは、クロロフロロカーボンによる成層圏オゾン層破壊のメカニズムの研究でございます。実は、今回、環境科学技術の分野では、大気汚染、水質汚濁防止、生態学、環境変異源に関する研究など、実に多くの方面の優れた候補者が推薦されておりましたが、現時点において最もインパクトが大きく、また優れた研究として、ローランド博士の業績が贈賞の対象に決定いたしました。
続きまして、受賞されましたローランド博士よりご挨拶をいただきます。
The composition of our atmosphere has been changing rapidly over the past 25 years. And concern over the pace of these alterations has become general during the last few years. Mankind must understand both the causes of these changes and the potential consequences for our common future. Because the atmosphere acts as a swiftly interconnected single unit, these problems immediately become truly international and demand global solutions. Moreover, the non-reactive chemical nature of many of the major pollutants ensures that atmospheric changes will persist for many decades and even centuries. The nations of the world must join together to prevent more serious damage to the only atmosphere we have. However, this is not a situation in which one region or country benefits while others suffer. Instead, our cooperative efforts can lead toward our mutual benefit. The present understanding of the atmosphere has been reached through the individual efforts of scientists from many nations in the strong spirit of international science. Moreover, the political representatives of the countries of the world have created and then ratified the Montreal Protocol for the protection of stratospheric ozone through regulation of emissions of chlorofluorocarbon gases. This regulatory agreement, the first of its kind, furnishes an outstanding guide for future international collaboration when additional measures for global self-protection are established as necessary by the scientific efforts of the entire world community. Arigatou gozaimasu.
ローランド博士、ありがとうございました。
それでは、医薬科学部会長としまして、エライアス J. コーリー博士への贈賞理由の説明を申し上げます。 コーリー博士は1948年にマサチューセッツ工科大学科学部を卒業。続いて大学院に進み、博士号を1950年に取得後、直ちにその才能を認められて、イリノイ大学科学部の講師となり、1956年には27歳の若さで教授になられました。その後、ハーバード大学から招聘され、1959年からは同大学教授となり、1965年からはシェルドン・エメリープロフェッサーとなって現在に至っておられます。コーリー博士の学問的興味は、ほとんど有機化学全般に及ぶ壮大なもので、この40年間に成し遂げた研究成果は、660以上の学術文献に報告されております。特に生物活性天然物の全合成で示した新合成戦略、合成新方法論の開拓は、標的分子に基づいて設計された独創性あふれるものでありまして、これらは単なる新反応や有用な試薬の発見を行ったというだけではなく、世界の有機化学者や薬科学者に絶えずインパクトを与えてきたものであります。
それでは受賞されましたコーリー博士よりご挨拶をいただきたいと思います。
Your Highnesses, members of the Government of Japan, members of the board and the selection committee of the Science and Technology Foundation, and esteemed guests. Please accept my sincerest thanks on this splendid occasion. In honoring me in this way, you recognize also the many creative and productive scientists in the field of chemical synthesis, upon whose research the advances in medicinal science depend. And you bring great credit to the research students who have worked in my laboratory over the years. The development of new therapeutic agents, so important to improving the human condition, is a very complex endeavor which requires both fundamental and applied research in such diverse fields as synthetic chemistry, biochemistry, molecular and cell biology, pharmacology, and clinical medicine. Crucial contributions may come from small groups working within a university or medical school, or the large teams of a major pharmaceutical company. Fortunately, these activities become synergistic through the exchange of information by written and personal means, especially at the level of fundamental research. Our own research has always been coupled with the educational process and oriented toward the creation of new knowledge in fundamental areas of medicinal and chemical science. Although such work has made massive contributions to the material and bodily well-being of mankind for many years, its contributions are easily overlooked, since important discoveries often precede commercialization by many years, and since the human drama unfolds only after success in the clinic. I hope that the recognition of the contributions of basic research in the field of medicinal science by the Foundation for Science and Technology of Japan will have a beneficial effect all over the world on the future of this field, especially with regard to financial support by government and private institutions, and with regard to the encouragement of creative young people to devote themselves to such activities. ご清聴ありがとうございます。
郡博士、ありがとうございました。
第5回日本国際賞の授賞式にあたり、ローランド博士とコーリー博士の受賞を心からお祝いいたします。今回受賞の対象となった両博士の業績はいずれも環境あるいは医学の分野における科学技術の進歩に大きく寄与し、人類の福祉に著しく貢献するものであり、ここに両博士に対し深く敬意を表したいと思います。今日、科学技術の進歩は目覚ましいものがあり、この進歩を人類の幸福に役立てることは極めて大切なことであります。フロンガスもかつては有用な物質として作り出されたものであり、当時はこの物質が現在のような問題を引き起こすとは考えられていませんでした。このような例は科学技術の歴史を振り返るときしばしば起こっており、科学技術を常に新しい広い視野から見直しつつ発展させていくことが必要であることを深く感じさせます。これからも科学技術の進歩が世界の人々全体のために良い方向に進められていくことを切に望んでやみません。ここに人類の繁栄と平和を目指す日本国際賞が世界の科学技術のより良き発展に一層寄与することを願い、授賞式に寄せる言葉といたします。
本日ここに第5回の日本国際賞授与記念の祝宴を催しましたところ、福田元内閣総理大臣として日本の各界各層を代表する指導的な方々が多数においでくださいまして、誠にありがとう厚く御礼申し上げます。この祝宴に先立ちまして、ご承知のとおり、日本国際賞の第5回のうちに滞りなく終了いたしましたことは、主催者として誠に光栄なことと存じております。この度、第5回日本国際賞を受賞されました環境科学技術分野のローランド博士、これを申し上げますとともに、このような世界の偉大な科学者とご一緒に食事を共にしながら親しくお話ができることを大変に喜ばしく存じます。また本席には日本の代表で
それでは日本流にし乾杯。乾杯。
Before we conclude, once again we would like to commend affectionate and dedicated support of the gracious wives of the laureates and would like to present a flower bouquet. Flowers will be presented by the granddaughter of Chairman Yokota, Ms. Natsuko Kozuka, and the daughter of Executive Committee Chairman Mr. Kawamura, Ms. Yurika Kawamura.
Choice by the JapanPrize Committee of Environmental Science and Technology as a suitable subject for the JapanPrize of 1989 is very good sign for the environmental scientists of the world. And I'm very pleased to be selected as the winner of the JapanPrize in Environmental Science and Technology for 1989. I hope that we will have more prizes of this kind in the future for scientists that are working in similar fields.
I'm very delighted to receive the Japan Prize in Science for 1989. It is a very great privilege to be honored in this way by the Japan Foundation for Science and Technology and from my colleagues in the field of science in Japan.